Okay, so I'm going to give you some basic notes. I'm going to stop here. Alright, so I'm going to give you some notes on naming acids, and these we've been learning about mainly naming ionic compounds because they have the most different ways to do it. And we learned also covalent compounds where they share electrons, but they're just really kind of simple because you just use prefixes and so on. Ionic compounds are a little different. As you remember, we had some that were binary, just two, just two elements, so binary. And then we had some polyatomic ions, so we'll just go poly. And then we had transitions, so we just say tran. And and now we're going to learn these acid ones. So these kind of go all together, but they're all compounds that form due to a charge. Two substances have opposite charges, positive, negative. That causes them to form a compound as those charges balance out. So you're going to see here, and I'm going to erase this now, you're going to see how there's really two types of acids we have to worry about, and they are binary acids, and that's single elements like hydrogen and chlorine bonding together, and then oxyacids, which are polyatomic ions joining to hydrogen. And really this is all about hydronium ions, and hydronium ion is just the hydrogen element or atom, and it has one proton, and that if it loses its an electron, say it has, we'll just draw this little, it has this one electron. Well, if it loses this electron, it's gone. It then only has a proton, and it becomes H+. They call it hydronium. And it has the ability to attract a lot of substances. Depending on where the substance is or how it forms, then that forms an acid or just forms a normal compound. So acids really, though, are something in solution. And a lot of times that solution is water, H2O. And if you remember, water is a polar covalent bond, and so when you put substances in water, they tend to separate that polar covalent bond, and that allows acids to form. So the first one I'm going to look at are hydronium ions bond with single elements. So the example here was hydrogen and chlorine. So they're really just the same name as we would use for the ionic compounds. So we would say hydrogen and chlorine. So if we're just going to name this the way we would for an ion, it'd be hydrogen chloride. The part that stays the same is really the names, but then we kind of add a few things. What we do is, instead of saying hydrogen, we say hydro. So that takes the place of hydrogen. And then we use this name, chlorine, and we would change it when we're forming a compound. It would be chloride. So if I write that out here. But now we're going to drop the IDE because we have to denote a way that it's different. So now we're going to say hydrochloric. So it's going to be CHLORIC. It's an ic acid. Hydrochloric. And then we just put acid at the end of it. Now how you know the difference for these, whether it's a ionic compound like hydrogen chloride or whether it's should be no in there, hydrochloric acid, is by this little term we had up here, and I'm going to move this up so it doesn't mess up your notes, is this AQ, aqueous, and that means the substance is in water. So the way you're going to know that this is an acid, hydrochloric acid, is because the way it's written, and it should say something like this. HCl. Okay, and if it was just like this, it'd be hydrogen chloride, but what you get after it is this little symbol, AQ. That tells us this is mixed in water, and that makes it an acid. And then we know when it has this after it, it becomes hydrochloric acid. Okay, so that's the binary, and you can add any of those little halogens or those little elements on the far right hand side of the table. So we could add fluorine and it'd be hydrofluoric acid. We could add bromine, hydrobromic acid, and so on. There's lots of different ways to do it. And not everything forms an acid, but just remember this rule. Binary acid, that means 2. Hydrogen, so this is going to be hydrogen plus a nonmetal, Nm. It can be any of them over there. You know, group 15 through 17. Okay, you could have sulfur, hydrosulfuric acid. You could have phosphorus, hydrophosphoric acid. But we know that that's, when we see that, it is just hydrogen plus one other element. And then it's the same, so if we were going to write, so let's say we had the name, let me just write a name here instead of drawing it. So if we had hydrosulfuric acid, we would just need to know, so if we had that and then we wanted to write the formula for it, we would just need to know the charges. And we know hydrogen is 1, right? And then we would just need to look on the periodic table and see what the charge of sulfur is and crisscross them, right? So let's do that. So if we look at the periodic table, here's a dynamic periodic table. We go to sulfur and we see it's in group 16. You should know from your periodic table it's -2. So if we go back to here, and yeah, get rid of my notes, I guess. So let me go back to them. Actually, I think I gotta move this up a little bit. Okay, so they're back, and down a little bit. And so we go back here, hydrogen, hydrosulfuric. So we write the hydrogen, it's +1, right? Always going to be that. And then sulfur is -2. These crisscross, 2 goes with the H, 1 goes with the sulfur. We don't need to write it. And then the formula would be H2S. Now if we just left it like that, it would not be hydrosulfuric acid, it would just be hydrogen sulfide, because we need to put the AQ next to it. Don't forget that. It changes the name completely. Okay, so that's a binary acid. I'm going to erase these. So if we go to the next one, polyatomic ions acids, or oxy acids. Let's go down the bottom here, move this down. These are acids formed when you get polyatomic ions on hydrogen. So the same kind of deal, and let me give you an example. So if we had hydrogen, and then we have carbonate, right? HCO3. So we know this charge is right because actually it would be a 2, right? So if you wanted to know the charge, this would be -2. This would be +1. They would crisscross, right? So this would become a 2. The carbonate would get a +1, but we're not going to write it. So let me erase these. So we'd have H2CO3, and again it has to be aqueous, or it's not an acid. AQ. If it wasn't AQ, it would be the same way we name a ionic compound, which would be hydrogen carbonate. We just use the name of the polyatomic ion plus the name of the cation. Okay, so then this would be called, it's a little bit different now. We don't worry about the H now. Like before, if you remember the last one, the binary is hydro something. So here we just take the name of the ion, carbonate, we take this off, and we add ic. Acids are always going to have that ic thing on it. That's going to be your suffix, and it's going to be carbonic acid. And that'd be how you name it. Another example, let me give you one more. I'm going to erase this one, so pause it if you need to. And then, so if we had another one, let's say we had hydrogen and not carbonate, let's have nitrate. So NiT, let's write this out real quick. Okay, so then we'd have hydrogen. It's a +1. Then we'd have to add NO3. And it's a -1, right? If you look on your chart. So then we get HNO3. That would be the correct formula. We don't want to forget, though, if it didn't have the AQ after it, it would be hydrogen nitrate. But here we put the AQ, and we would say it's nitric acid, just as we named this one. So we'll write it out, nitric acid. Okay, so there's an example. I want to actually show you one more, though. One more change to this, or two more. So there could also be a couple differences. So just like when we talked about the 8 ion, and then there could be an additional oxygen or one less oxygen, we're just going to talk about the one less, and then I'll add the other conditions in class. But let's say instead of nitrate, we had nitrite. If you remember, the ITE just tells you instead of being NO3, it's NO2. Same charge, -1. You always want to check that, though. Don't assume that it's the same. Let's erase some of this to show you this. So instead of nitrate, we then have nitrite, which really means it's just the 8 ion that's lost one of its oxygens. So then we're bonding this hydrogen to it. It's a +1. And then, so the new formula would be almost the same, just one less oxygen, HNO2. And then it would have to be aqueous, right? So then the name of this, instead of an ic acid, it'd be an OUS acid. So OUS is the suffix now. So you lose the ic, and then this is an OUS acid, an US acid. Okay? So then it would be no hydro again, just nitrous acid. Okay, and you'd write that. Okay, and that's kind of how you do it. If we wanted to look backwards at one, so let's say we had a formula. Let's say we had SO4. Okay, then we have to figure out, do we have this right? Let me see. We want to remember the charges, -2 +1. Okay, so that really would be H2SO4. We also want to remember that we have to have the AQ, the aqueous, after it as well. So AQ. And then this would be sulfuric acid. Okay, but let's say we went the other way. Let's say we had sulfurous acid. We just had the name. We kind of got to know what the prefixes mean. So if we had that, we'd have to remember all these acids are going to be formed by adding a hydrogen. And then we're going to add sulfurous. That tells us there's one less oxygen. So then we have SO3. Same charge, 2. And then we have to write AQ. And that's kind of the notes I wanted to show you. Just check them out. If you want to annotate something, you can. But if not, we're going to discuss it in class again. Talk to you later. I hope you had a good weekend.